Let's learn about Anscombe's Quartet. Let's say you have 4 data sets. And for some numerical data analysis, you find that the 4 data sets have the same mean and variance for both the x variable and the y variable. And the 4 data sets also show the same correlation coefficient between x and y. Let's also say they have the same linear regression line. And let's say they also have the same r squared. So again, through numerical data analysis, you find all of these very, very same, pretty much identical values in terms of descriptive statistics. But the underlying variable is actually very different. And the only way to find this difference, or one of the key ways to find this difference, is actually to plot your data. So what Anscombe's Quartet is, the statistician created these 2 examples where he had very different data points. And this one, for example, this is a nice straight line. This one a curved set of data. This one has a fairly straight set of data with one huge outlier. And then this one, a vertical column of data, which has a huge outlier over here. And in this example that Anscombe created, he actually found that all 4 of these data sets generate the same mean correlation regression line in r squared. So from a purely numerical point of view, you might think that the 4 data sets are pretty much identical. But when you actually graph it, the 4 data sets are completely different from each other. So the key takeaway here is just a lesson to plot your data and not just depend on these numerical summary statistics to understand your data. Plotting can show very different relationships. So after plotting this data, I would probably do some sort of quadratic or cubic relationship. If I plotted this data, I would try to figure out how to deal with this outlier. And if I plotted this data, I would try to figure out what the hell this is, and then also what this outlier is as well. And that's Anscombe's Quartet.